Hello, so today's video is really for Java developers, former Java developers who find it hard to understand the concept of asynchronous functions in Node.js. Now, if you Google asynchronous function example for Node.js, you're going to find something quite similar to this, which is I have an asynchronous function here that logs a little message, then calls another asynchronous function, and it then prints what that function returned. And because it's an asynchronous function, that function will return a promise. It doesn't actually return a result, it returns a promise. And it then waits on that promise P to be resolved. And once it's resolved, it will print what that result is. Because when we say await P, await the promise, what we actually get back is the result of, the resolved promise. And this little function that we're calling here, take your time, all it does is it creates a promise, and that promise has a timeout. And when the timeout is like 10,000 milliseconds, so that's 10 seconds. So after 10 seconds, it will time out and resolve the promise with the result resolved. So this is what it does. Now, when I run this, what we see is it says calling async function, there we go, then immediately says function returned P, and that's the promise. And then after a while, which is 10 seconds later, it says final result is resolved. So what happened here is the thread of execution is like this. It says this log message, call the function, and immediately print the promise, because what we immediately get back from that function is this promise that's been created up here, which is then resolved after 10 seconds. So basically it immediately gives us the promise, then we can inspect the promise, we can look at it, it's like an object here as you can see, and then we await the promise. Await is something that in Node.js we can only do in an asynchronous function. So we await that promise, and then we print that final message. The whole idea of asynchronous functions and await was really introduced to Node.js to make this whole asynchronous I/O issue a bit easier to understand, where we didn't have to chain promises one after the other in our code, which would get deeper and deeper and deeper and get really quite confusing for people. It made it easier to write that code and to write code that is easier to understand. So we've got this as our example. The way we would do that in Java is probably like so. So we'd have a little class here. It has a static main method, which basically means it's an main entry point into this Java program. In here, what we do is we print a little message that says creating new thread, very similar to our asynchronous function example. And then we create a thread with a runnable that basically just has very little in it. It just makes the thread sleep for 10 seconds. So that's, 10,000 milliseconds again. So the thread sleeps for 10 seconds. And then it calls a little setter method here to set our result here from pending to resolved. So I have a little up here, I have a little setter method and a little getter method, which are synchronized methods because we're dealing with threads here, but never mind, in this example, there's not much going on. But, just to do the right thing, these are synchronized methods. So there's a setter and a getter method to set the result from resolved, from pending to resolved. And then we start the thread and then print a message that says the result is whatever it is at that point. And at that point, if you're a Java developer, you will know that at that point it will be pending because that's what it was before. So it's pending, would say our result is pending. Then it joins the thread. So we wait for it to finish. A bit like, it's our equivalent here of await. We just wait for this to finish. And then we print a final message that says thread has finished and result is get result. So when I run this, let me just move that up a bit. Switch to terminal. When I run that, what it does is it says creating new thread. It says result pending. Then it waits for 10 seconds. And then we're going to get result resolved. there we go, result pending, thread has finished, and result is resolved. Because it's now set it, after the 10-second, it's set it to resolved. And the reason it waited for that, why it just sat there and didn't do anything, is because of the thread.join, which means that we're waiting for that to finish. Now that's great. And now we think we have two equivalent things that do the same thing. Well, the thing is they're actually really, really, really different. So let me demonstrate that to you. I have another asynchronous function here. In our previous example here in Node.js, in this asynchronous function, we just set a timeout. And then at the end of the timeout, we set, we resolve the promise. Now in this asynchronous function, we don't do that. We still return a promise, right? This function still returns a promise. But rather than setting a timeout, I do some big integer calculation here to make it go as fast as it can, doing something that takes quite a while to do. And also where, the Node.js, the JavaScript engine can't optimize this code. And the same applies to Java as well. The just-in-time compiler won't be able to optimize this code away because it's big integer calculation. It just has to do it. And it's really, because it's string-based, it will take a long time. So the reason I use this is to create something that runs at full speed for a period of time to sort of emulate this idea of, they previously were at a timeout of 10 seconds. Here we're going to run it for a while. Don't actually know how long this is going to run, but it's going to run for a while. So when I execute this, I need to switch to debug console here. So when I execute this, it says calling async function, but look, it hasn't said function returned promise. Because this, it's, in Node.js, you have a single thread of execution. This is still running. It never relinquished control. It never said, this, I'm waiting for something, carry on. No, it never said any of that. It's running at full speed, and I'm in a single thread of execution. And then when it finishes, here, it just happened. That was good timing. It says function returned promise. It still returned the promise. And then immediately it says final result is resolved. So this is quite different from what we had before. Now, as you know, as a Java developer, if we do the same thing in Java, when we have a runnable where we do the same big integer calculation in a loop, which takes quite a while, and j ends up being a big number, in fact, we should print it in a minute. It's probably quite a big number. But, it does this big integer calculation here as well, going through that loop. This is a big number. Was that 300 million, 30 million, something like that, going through that loop quite a few times. The difference here is that this thread that we create here, thread new thread from that runnable, and then we start that thread, is a separate thread of execution. Just because this is executing, it doesn't mean that this main thread stops. In Node.js, as we saw with the asynchronous function example, the main part of the function, it has to wait for that promise to actually do its calculation. It doesn't just carry on. In this example, when we run it, so let's run that, it looks exactly the same as before. Where previously it says creating new thread, result pending, it said exactly the same thing, but previously this went to sleep. Here, thread.sleep for 10 seconds. Here, it now runs at full speed. And in fact, if I show you here, you can see that there's one processor on this Ubuntu virtual machine. Oh, it's now finished already. But there was one processor running at 100%, and it was doing the calculation at full speed, right? We saw that there. Now, the interesting thing is, first of all, this is now different, where we thought that this async function with a timeout and this thread with a timeout, with this thread.sleep, are equivalent things. They are in a way, but they're also very different because, as you can see, in this example where it's doing the calculation, it prints it in the same order as when it's not doing any calculation. Where when we do this in Node.js and we do the calculation here in this promise, then it doesn't print the message function returned because this function doesn't actually return until the promise is resolved, because it has to, there's only one thread of execution in Node.js. Now that's really interesting. There's something else that's very interesting, which is in Java, if we now go in here and say, let's create 4 threads. Why create 1? Let's create 4 threads. So we've got T1, T1.start. We've got T2, T2.start. We've got T3, T3.start. So we're now creating 4 threads. When I run this, then I'm going to show you something in HTOP. So this is now running, and you can see here in HTOP that all 4 logical processor in this Ubuntu Linux virtual machine are now running at full speed, because all 4 of these threads are running at the same time, and Java has distributed it onto 2 different processors. The operating system has distributed those 4 system threads onto logical processors. So they're all running at the same time, and then it says result is resolved. If we do the same thing in Node.js, and we say rather than just calling this once, let's call this several times. We call it 4 times as well. So there's P, P1, P2, P3, and then we also await the results for all 4 of them. So P, P1, P1, P2, P3. Because we already know that, this, when it runs at full speed here, in each of these cases, it doesn't immediately return. It does the calculation first, then does the second one, then does the third one, then does the 4th one. Gone a bit mad here, haven't I? P1, P2, P3. I'm sure I said P1, P2, P3 and I've typed 2, 4, 3, 4. Anyway, so we saw earlier on that this first one didn't actually relinquish control and then carry on with whatever was after it until it was finished. So what we're going to see here when we run this is we will see, okay, out for a second. I have of course gone mad because obviously these are constant. I can't redeclare them all the time. So let's run this. And as you can see, it's now calling the async function. So it's giving that message. It's not telling us anything about anything else. Well, actually I took that long message out, but also I want to show you something here. Because when I look at the 4 logical processors, even though I'm calling the function 4 times, only one of them is, of course, fully used. And that is because we're in a single thread of execution. It does the first one, then it will do the second one, and then it will do the third one, and then it will do the 4th one. So each of these run one after the other. Each of these calls means it runs one after the other, unlike this example here in Java. So this is totally different because in Node.js, single thread of execution. In Java, when we create a thread, obviously each of those has its own thread of execution. Is one better than the other? Well, that's to be debated. It's not something I will resolve here, I can tell you that now. But I just wanted to demonstrate this to you today to help you understand better what the difference is between an asynchronous function and a thread in Java.